So this is the sustainable code panel. I'm very happy to be moderating this session. I'm Valerio. I will be, as I said, moderating the session. I start presenting the three invited speakers we have here. Certainly not how to use this. So we do have today the pleasure to have Uljan Sharka, the CEO at iGenius. We then have Jessica Greene. She's a back-end engineer at the Ecosia and an active community member and PyLadies Berlin co-organizer. And we also have Chris Adams, executive director of the Green Web Foundation, a non-profit organization who's willing to reach a fossil-free internet by 2030. So use round of applause to them, please. That was easy. Yes, has an icebreaker, and we actually need lots of ice here. It's very hot. Okay then. Just to briefly give you an idea of what we had in mind, we start discussing. We had some question. We start, and then whenever you had any question you want to intervene in the conversation, or you pose question to the specific to the panelist, please feel free. We'll bring you the mic, and then we will proceed from there. All right. Okay then, so I'll break the ice by, I just want to say that I'm a fellow member of an institute which is called Software Sustainability Institute in the UK. And so when I started learning about sustainable code, I had a completely different idea what this panel would be about. So sustainable code from the Sustainability Institute perspective is the sustainability of the code, not the sustainability of the code within, with respect to the environment. And so, why do we need to speak about this?
Okay, is there one person you're aiming at?
Whoever wants to take it that, and then we can take it from there.
Okay, so the question, as I understand it, is why do we need to care about the sustainability of code outside of just whether it's sustainable to maintain the code?
Exactly.
That's the yeah.
Yeah.
All right. So on a really, really basic level, the energy has to come from somewhere, surely, folks. Yeah, and most of the time that's coming from burning fossil fuels. And we've got a whole kind of climate crisis thing going on. So maybe that would be one thing we might want to think about. That's one way we can talk about this. And where I work at the Green Web Foundation, we talk about sustainability in kind of three main ways. We talk about if you're a technologist and you want to do something about climate, you can think about consumption, which is what kind of resources you might be using. We talk about intensity, as in how harmful are the side effects of those things that you're creating. And one example might just be using, say, green energy rather than fossil-based energy. And then the final one is about direction, which is essentially, what am I using this code for? Because you can use very green energy to do very, very non-green things. And I think I'm going to hand over to my other panelists here before we dive too deeply into that one. Sorry, straight to you, I suppose.
I guess so. I think that was a really good breakdown, and I can tell you an example maybe, because the company I work for, Ecosia, is kind of really living in the spirit of trying to think about where profits go. So if you're not familiar with us, we're a search engine, and like all search engines, we're earning revenue from ads, and we put this money into planting trees. So our tech isn't inherently sustainable itself, but we can choose to do something with it that is good for the climate. And maybe I'll pass on to you.
Absolutely. I mean, this is such a broad argument, and I'd love to add more on what was said, which I totally agree. So to me, sustainable code is actually making work more efficient and effective and increasing impact. And actually, if you think of how we write code today, there are a lot of best practices that we are already implementing to make things sustainable, such as, for example, composable applications that actually leverage existing components to build new applications without having to write everything from scratch. Incremental learning, as we add AI and machine learning to our applications, transfer learning between applications, or actually using practices that don't duplicate information when it's not needed, but actually reading it in real time as much as we can, and then when we have performance issues, potentially caching or doing other things that would be sustainable for the code, for the application, but most importantly, it would also increase the quality of the user experience. And this is another argument that, for example, is I would say underestimated. So sustainable code is not just about the backend, but it's also about the impact on the end user interface. So how much we designed with the user in mind, and how this can actually cut a lot of middle steps that they can have an impact not just on the business but also on the climate, because of course printing a lot of paper with manuals and doing trainings and a lot of activities in the middle that if you look at the end-to-end cycle, now I don't want to get it so broad, but it's really opening your mind about how we can make things more efficient and more effective, and actually making this a mindset. This is not something new that we are reinventing. It's about implementing best practices at their full potential and having this mindset of sustainable architectures first, and then continue down the way of the I would say value chain until the end user experience.
And I guess that now the follow-up question might be probably starting with you, Uljan, is why should we be thinking about making our code sustainable? Is there any reason about the obvious one?
So actually, this is to increase impact, I think. At the end of the day, the end goal is to increase impact overall. And as you look at the value chain, from when you start designing the application to actually using it and measuring, as Chris mentioned, the impacts of that application with respect to what kind of energy are we using in order to actually power the computing behind the application. Or as I was mentioning earlier about the what is required to actually put that value that we created into work and make it accessible at par for everyone without actually increasing the digital divide, but potentially closing it in full. So I think the short answer to why is creating more positive impact on the full value chain.
And a follow-up question maybe for you, Chris. Do you think that the impact has anything to do with what we have in mind with our pipeline? So the kind of effect we have when we run code and we have executional outcomes we want to achieve.
I think in some cases it might be worth thinking. Okay, to answer that, the question is like, are there unintended consequences I should be bearing in mind? Is
yes,
that the
exactly.
Question? Okay, so let's say if I'm a machine learning engineer and my job is to increase the extraction of oil from the ground, I kind of know what my goal is, yeah? And like that might be an example of a really, really good way to really sustainably use really sustainable code for something which is not a particularly sustainable outcome, all right? Especially if you look at the science. And like to give you ideas and to give you some idea of like the magnitude of this kind of stuff, let's say look at 2019. Microsoft is one of the real leaders in sustainable code right now, right? They run the organizations like they're one of the founding members of the Greene Software Foundation. They're very much a leader in this field. They are also the market leader in the oil industry, helping drill for oil. And like one contract with ExxonMobil, when you look at the uplift and how much you can get out of the ground and get burned, it's about the same carbon footprint as Facebook that entire year, right? So this is why you need to be thinking about not just a sustainable code, but also what you're planning to do. Now that is like an example of, well, I'm not sure if you're an engineer and you're working on that, you would say that's unintended. You might like, I'm paid for this and I might not be happy about that, but I did it anyway. There's a whole thing there, but that's possibly outside this discussion. But there are absolutely kind of unintended consequences of this. So like when we're talking about, say, I think, Uljan, you mentioned about this idea of, okay, where am I shifting the work to? So if you were, say, designing, say, a particular website, which leads to people having to update to a different device, for example, it turns out that there's a whole amount of energy going into turning sand into like iPhones, right? So there's a massive carbon footprint there that we need to be thinking about. And that's possibly unintended impact. So there are totally examples that you might have along there. And like this is an example of, if you were going to think about this and you cared about this, you might think about, well, the accessibility one thing. And this is actually one thing that we were discussing before, the idea that, well, okay, if you're going to be building digital services, then having an accessible one would mean that people aren't being forced to upgrade to use another kind of technology, for example, or another phone or something like that. And this is an argument that you might actually be making. And this is one thing we were speaking about before. I mean, this is one thing we spoke with. You mentioned before how it was quite nice that, yeah, we have talks about accessibility here because it turns out there are all these other benefits in addition to just making it slightly more accessible to, say, certain groups of people. There's a whole set of other reasons why you might care about this stuff. And I'll hand over to you because this is one thing that we were speaking about before this panel, actually.
Yeah, and I think to add to that as well, it's about making it very visible for us all to understand the impact and what we can do. So something that we started to talk about when we were having the conversation between the four of us was what are the ways that people can take action in that way that, you know, when you hear for the first time, add an alt tag to an image, and then you can spend maybe half an hour, depends how many images you have, but like you can really just take this small amount of time to have a big impact. And one of the difficulties with this kind of work is a lot of the impact that your architecture and your code and your programs have is kind of not visible, and it's not visible for a reason. So a lot of the time when your code is running somewhere in the cloud, like that's maybe all the information that you kind of need to have to a certain extent when you're a programmer and you want to make sure that it's working and that it's up and your users can access it. But then it's kind of only been recently that you can even dig into the actual amount of like carbon that your code is costing because of the level of compute. And one of the things we were talking about is that there's now some tooling with, like, I think a lot of people host on AWS, and you can kind of start to slowly get these numbers out, like maybe not the full picture, but some of it. So one thing we've implemented, and I think both of you mentioned that you've done something similar, is having a tech KPI, like a goal within your technical team to measure what your current status is and go in one direction of like improving it, not adding more to this debt. So I think visibility and talking about things and raising awareness and being able to put numbers on it is a really important first step. And yeah, I don't know, do you want to dig more into that? Because I think you mentioned.
Yeah, actually, I wanted to add also on the more on the why, because the why today, of course, is it's something connected a lot with the technical aspects of what am I doing and what is the impact of this work. But in the future, it will become actually much more important. We're already seeing, for example, VCs evaluating companies these days, looking at the Greene KPIs, how much do they fit into ESG frameworks and how they perform with respect to specific socioeconomic and environmental KPIs. So there's going to be a lot of, I would say, push from the market in order to achieve this. But this is going to take time. So I think this is an opportunity for us to prepare in advance and to actually contribute to this huge shift that is going to benefit us all. Because at the end, it's not about the code or the infrastructure. It's about people and the planet, right?
Those are all very good points. And actually, I had many questions in my head while you were talking. As in, well, one obvious... you already started saying that you do foresee this as a good investment for the future, as in it's better if we start early in the process because we're one direction we're going to anyway. And so we briefly introduced this ESG discussing for the panel before. Maybe you want to, any of you wants to introduce what ESG is to the audience?
All right, so ESG it stands for environmental, social, and governance. These are kind of factors that people who invest in organizations like maybe a venture capital fund or a pension fund that you might be indirectly invested in, they use these as ways of figuring out which companies should I be invested in and which companies should I not be invested in. And that's going to have an impact about whether they're able to expand or borrow money or do things like that. Now, the thing is, it's really, really early days with this stuff. Like, for example, ESG is something which people haven't really figured out right now, such that you end up with quite strange results right now. So companies like, say, okay, you've heard of like Tesla and you've heard of Exxon, the oil company. Right now, Exxon ranks higher than Tesla in terms of a good ESG company because they're very good at disclosing certain things about that. Now, maybe that, and this is what I mean by things being early at the moment. People haven't figured this stuff out, and it's going to become more and more of an issue as people realize that, well, we might be able to change the physics of climate change, but we can't change it. Sorry, but we can't change the economics of climate change, but we can change the economics around climate change. We can choose to invest in certain companies or other companies. And in many cases, there's lots of organizations that are quite exposed to some of the changes that we have here. But going back to the whole idea about ESG, this is basically a kind of measure that people are currently trying to figure out to decide how green a company is and whether they should or shouldn't either be working with them or investing in them or anything like that. And you actually see this in quite a few places now, trying to figure out how to do the kind of green thing in terms of what kind of is in their sphere of influence. So, for example, in the UK, if you sell any public services to the UK government, you need to be able to demonstrate that you have a climate plan, and you actually have really explicit targets about running digital services on green energy and recycling all the actual tools, all the kind of hardware that you do use to deliver digital services. And if you're not compliant, you're just not going to win those contracts. So this is a thing that's coming right now, but it's still kind of early days, and people are still figuring this out. And this is one thing that you're seeing in Europe, probably more so than other places right now, because Europe, in the EU Commission, for example, they spend something like $45 billion euros each year on IT, and they're trying to figure out how can I use this 45 billion euro carrot to kind of incentivize some of the kind of greener activity from the tech industry right now. Because, well, like I said before, the energy has to come from somewhere, and it turns out that it takes energy to turn sand into iPhones. So we probably have some kind of responsibility on this. I'll hand over now because that was probably more than just defining ESG there, I think.
Yeah, that was brilliant. And I think, please feel free to add anything.
I mean, this is a lot of information, but I wanted to say that the good news is that we don't need to build actually our own green data centers to achieve this, you know. A lot of people are taking care of this. So it's more about doing things right. So as mentioned before, starting with the architecture, and starting with those small decisions that down the way can actually make a difference when you look at them as a whole. So every single decision we make every day in writing our code and shipping our applications can be a contribution to the full picture, actually, of the ESG framework.
I very appreciate how the discussion is going, because I think now we moved into what is closer to management and how we can put a step forward into making this to happen. So we introduced ESG, and so we realized that it's all a matter of how do we set up things at a company level, and so we're not touching at all any technical details yet. And so I was wondering, how do you think that having a good board of directors can have an impact into make this happening for a company, for example? And you mentioned that making the code sustainable is indeed more a state of mind rather than a technical approach. So I think it's all about decision the management can take in the company, and so directions that the management could decide to go rather than not going. Like, you know, I would prefer going there instead of anywhere. So do you have anything to add into this?
It's the same as accessibility.
Brilliant.
So, like, you know, I mentioned the alt tags earlier, but if you don't have it all the way through, it won't happen. You need accessibility considered from the start, from the product managers, from the designers, and you need buy-in from whoever's in the C-level to make this happen. And I think it's the same for this.
That's a very brilliant example. I can even understand that. So,
thank goodness.
So I was then wondering, speaking about this and decision at the management level, do you think that having a diverse set of point of views in the direction might benefit in, you know, taking a lead into making this change happen?
Yeah, I think in the Northern Hemisphere, maybe like in Europe and the US, we're quite good at thinking our ideas are applicable everywhere and everyone should adopt them. And I think particularly when we talk about the climate crisis, we have to respect and understand that most of the people who are already seeing this, who have been seeing and affected by this for years and years, are not based in the Northern Hemisphere. They're predominantly in the Southern Hemisphere and they're predominantly along the equator belt. And we have a responsibility also to ensure that they're enabled to put into practice their own ideas and their own innovations. Because I think what I hear a lot is saying like, oh yeah, we can like work on this technology that will then go to the continent of Africa or go into South America and be used by people there. And that's something that Ecosia also has to be like really mindful of, because we're a German-based company and predominantly all of the folks that are employed directly by Ecosia as technologists are based in Europe. But of course, mostly we're planting trees in the equator belt because this is the diversity hotspots, and it's done by people who live there and who integrate this into their cultures, into their communities, and we have to be very actively listening to them.
And then I think the follow-up question might be, so you, Chris, mentioned about the example of Microsoft investing in one company doing green energy and another one doing a completely opposite thing. So I think now the question might be how big tech companies might have an influence in this in taking this decision.
All right, so I think there is so you can actually look at what's happening right now with a number of large technology companies. So who uses AWS? Okay, half the room, right? They will generally they will do they've said in many cases they will do what their customers are asking them to do. Now, who here has ever asked AWS about their climate plans, right? Or know some yeah, right? Like to an extent, like it might seem a bit like I'm just like bashing these two companies and make all these really, really effective, cool tools, right? But it's kind of on us as well as professionals to be asking about this, or at least realize that some of it is on. We have some responsibility to be asking some of the questions, so they can actually make the argument internally to say, well, we've had all these people ask us to be speeding up on green energy, for example, in addition to just asking about a newer version of serverless Postgres, for example. Like there is stuff like that we need to be prepared to ask, and we need to have some degree of knowledge about this, because for the most part, they're actually doing a lot of things which are very, very, very effective, as long as you don't look at the whole helping people drill for oil thing, right? So like, for example, most of the infrastructure that you'll use in lots of the cloud environments like hyperscalers, they'll be at double-digit utilization, whereas most of the servers that we might be using will be like 3 or 4%. So like that's like 10 times more efficient immediately, right? So some of the things you can do if you just want to actually have like more efficient kind of greener code, and is basically essentially use a bunch of big tech stuff. But if you're not going to be asking these questions, then I kind of feel maybe we should be doing that at least. Or if you don't necessarily feel like that feels a bit weird, saying the thing we should do is consolidate around the two big leaders of drilling oil, maybe we should do something ourselves and say, well, do we want to kind of support smaller providers? Do we want to think about having open options so that we don't necessarily need to be dependent on them? But if you're going to do that, then you need to be prepared to have a conversation about like the price points between this, because large providers can happily spend 100K to buy a customer, and if you go to DigitalOcean and ask for 100K of free compute credits, you might not get that. You might get laughed out of the room. I don't know. I haven't tried that with DigitalOcean specifically. Please do tell me if you have. So there is some stuff there. Okay, I'm going to hand over because I don't want to be just make this all about big tech, because there's loads of really, really cool things you can do from a programming point of view as well.
Perfect segue. Perfect segue to you, I think.
Yeah, actually, I wanted to say that as the KPIs are being built, and that was a brilliant example of how actually you can take action starting now. And I run a software company, and it happens with a lot of things, where people come in and say, hey, we need to improve this as a company because it can be done better. This is one of those things that we need to add to the list that we should push companies for improving. And I'm pretty sure that actually it's not going to take so long where we're going to see these KPIs appearing also for finding jobs. When we are going to evaluate a company, which company I'm going to join, you're going to see these KPIs being listed as those that could make the difference for the company you're contributing to, because that company is going to make your work even better by multiplying the positive effect on the full value chain. I think that another important action that we might take is actually get ownership and make this something that it's by design and by default implemented in the process. So to my view, as a tech CEO, I see this under the DevOps team, who today can actually the CTO as well. But again, it's something that the individual should push for. It should be something that you ask for. And I think then once that action has been made, you're going to see the positive effects happening one way or the other.
Brilliant. I was wondering, well, unless there's any, is there any question from the audience so far? Well, they come along. Anyway, oh, brilliant. Sorry. Thank you.
You mentioned in the beginning how you're working with the SSI, right? And they focus on, I've been following SSI's work, and they focus on sustainable code rather than code for sustainability, like environment related. So do those two things go hand in hand? Does sustainable code itself help with the sustainability with respect to the environment? And I mentioned this because you mentioned how reproducibility helps with reducing the carbon footprint. And that is also something that is a part of sustainable code. So that's why.
Because I think we also discussed this, we had a little chat before because we were like, okay, what are we going to talk about? Because it's such a big topic, right? There's so many aspects to it, and I think you're totally right. It's there's all these intersects as well of where different things have an impact. So of course, one thing we were talking about was tech debt and the role good documentation has, and maybe ensuring that people are onboarded to your code so you don't have these knowledge drop-offs when someone leaves. I think lots of people can have had that experience. So there's all these different ways that we can build up to then also have an impact on sustainability in the climate sense. So I think it's a really, good point. Do you want to?
Absolutely, they do go hand by hand, and it actually depends a lot on the use case, because we were mentioning earlier that actually if you build a heavy AI application, which actually emits more carbon footprint than the one that you're going to reduce as you're building it for making another system sustainable, of course it doesn't make any sense. So this is why it is super important to build these KPIs and start measuring. As of today, we're measuring, of course, the impact of how we can make a system sustainable and actually how much impact we're delivering there. But we're not measuring what's happening before that, which potentially can make things worse than they were before. So this is why it is important to actually look at the use case and implement the green code approach beyond actually the fact that we're building AI for making other systems sustainable. The system itself should be sustainable first. Yeah.
I'm gonna have to. I'm not sure if I'm disagreeing, right? But I think when people ask about this, it's a bit like saying, what's the best way? Okay, they're both good things in the same way that having RAM is a good thing and having a hard disk is a good thing. But I shouldn't confuse the two, right? And I think this is why this is quite helpful to realize that these are two separate things in many cases. So, and I don't need to add more than that. We've given loads of examples of how you can make a really, really sustainable thing itself do really unsustainable stuff, and likewise the other, vice versa. And I think it's easy for us to reach for things because who hasn't enjoyed making something go faster or more efficient? You're going to feel good, right? So you can think, well, I guess that feeling that I get of feeling good there is well, if I do something good for the planet, it makes me feel good. Maybe they're the same thing. They're not the same thing, but they both are kind of good things to have. But that's the only kind of direct answer I would give for that one specifically. In the same way that RAM is good, hard disk is good, shouldn't really confuse them. Yeah. All right. Next question, I suppose.
I think that we're moving a little bit towards more technical level. So I was wondering if any of you has any particular example they want to share with the audience, as in, for example, one existing software that has become greener in some sense.
Yeah, I'll go.
I promise I'm not doing any marketing about iGenius, but actually the use case fits very well. So we actually operate in the BI space, and we have built a product which is named Crystal, which augments data with a human interface. So basically, we use natural language to let people query information in natural language. So you can think of it as a Apple, Siri, or Google Alexa for Alexa or Google Assistant for the enterprise data. And when we actually started building the technology, we looked that most of the tools out there were replicating information and were trying to make things efficient in memory in order to actually make the processing that was required happening in order to provide this level of accessibility. But that actually would come with a lot of inefficiency, right? So I pushed a lot together with the leadership team at iGenius to actually have a system that would be able to treat data in a way that would use less computing possible. So what we did is build a system that where it is possible, we would actually query the data in real time. And where actually we had performance issues, we would leverage AI to create middle layers that would manage the complexity by just caching only the data that was necessary to cache. So when we started marketing the solution, we were not actually aware of the impact that we were generating. But as we got adoption by Fortune 100 companies that have a lot of data, as you can imagine, they started publishing these amazing case studies where they were getting 50% less computing power spent on the same use case. They were getting more adoption, but this goes beyond the infrastructure thing. It's about the design of the application and, again, the use case. So this made us realize how powerful these small decisions down the way can be when you then see the thing in action used by the end customer.
So would you rather say that we're shifting towards having the so-called big data into something like very tailored data?
Small and wide data. Actually, there is a term for that.
Okay.
Small and wide data, which is more contextual and leverages context in order to actually make the whole experience smarter around the end user and use less computing power and less data overall. And it is crazy, but actually it has been proven to be more efficient and effective than the big data approach, where you pre-train a model with all the data possible you have, then you put it into context for customer A running in industry, let's say financial services. Then the same customer leveraging the same model is not going to be satisfied for that model because actually they have their own jargon, they have their own process. So by taking the data they already have and training it for the specific use case, so with a small and wide approach that leverages the context of that specific customer, you would actually build a better system and leverage less computing power. And this is without a doubt the future, and also large companies that have been training large models over time. Now, it's not the right time to actually make this statement because, of course, there is a lot of news around large language models trying to push new NLP use cases out there. But it is without a doubt the direction where search is going, for example. So everyone is now talking about search around you. So you actually search for something and the context around you has the priority beyond what you could search all over the world. So I think that the needs of the end user are somehow already guiding this kind of trend. We just need to actually understand it and play in advance and be complementary to what is already being done out there. And the complementary part, I think, it's super important when we design software today because we usually tend to actually rebuild things. So we have ended up with all of these middle layers in between data, for example, and people that, at the end they create more complexity than they add value to an end system. By being complementary, I mean actually trying to not destroy what have been already created, but just to add a small piece that complements what already has been built and actually add value with that piece by building a new use case.
Wonderful. Is there any other example from different contexts you might have? Because I could, yeah.
We know that Python, I'm at a Python conference. We know that Python is nice to use, not necessarily the fastest language around, right? Yeah, and I don't really know Go very much, but I do know that in lots of cases, when there's a problem that I understand quite well, maybe it'll make sense to use some of it in Go, for example. I'm I'm speaking to Jessica because you run the women. You've probably got much more experience with Go than I have, basically. So that's why I was going to ask you about some of this because yeah, there is like a kind of hierarchy of languages that where it's kind of useful to know about. And I might hand over to you now because I'm out of my depth now when I'm using the word Go.
Yeah, I mean, I think there's languages that lean into helping us understand more. For me, what I really grasped when I started to learn Go was understanding mechanical sympathy. So understanding what my code that I wrote actually was doing under the hood and how if I wrote it one way versus another way, it would have an impact on like maybe how much compute power it required or, kind of like what the machine had to do to get to that outcome. And I don't have a traditional background. I am a self-taught / community-taught developer. But grasping that for me was really interesting on the one hand of like, oh, I can control this in some way, but also to then be able to think about what we're talking about of like, how can we kind of optimize or make things more sustainable. I think, understanding what your code does is a really important play of that. And yeah, I think there's like languages that lean into that more, like it's a more lower level language. So of course you have a little bit more access to things to tune. But I think we're seeing more things in Python. I don't know if anyone watched Liza's talk earlier on Python 3.10 and pattern matching, and she was kind of like showing this new feature that we have in the language that actually has leveraged a few of the things that other languages do to kind of do it in a really elegant way and a way that's more performant as well, which is super, super cool. So to bring it back to Python.
Yeah. And just to say, like, okay, I got love for Python and I use Python all the time. And you can use Python to call really, really fast stuff for you, right? Who uses SQLite here? Okay, everyone should be putting their hand on it. It's on half of your watches, right? So, but if you are used to the idea of like in-process data analytics, has anyone here used DuckDB before? Oh, wow, you're in for a treat. Imagine something which is able to turn basically kind of biggish data into like stuff you can run on a laptop, right? So it's something, imagine like something like SQLite that can do the same kind of querying language with SQL, can speak natively to kind of Parquet files. So like something which would maybe be a few hundred gig, you cut it down to maybe a tenth of the size. And it's as easy to use as SQLite, right? Now, that's written in C++, but you're calling it from Python, right? So you don't need to be like having these weird kind of language laws. And this is one thing that's wonderful about Python is that you can just call into all the hard work from other people. And in some cases, if there's an API and someone else has a faster version of the API, you're laughing. I mean, okay, Redis is a good example. Redis is pretty fast. There's nice Pythonic interfaces to Redis. But there's a piece of software called DragonDB, which is basically Redis re-implemented to use like a shared nothing architecture rather than the single-threaded approach that Redis has had for the last like 13 years. Because 13 years, computing moves along. It's 25 times faster than Redis, which is already really, really fast. But you don't need to know that C++. You're using it in Python. There are all these tools like that. There's a phrase like increasing your hearing is called scale in, which is basically API compatible, but massively more efficient. So for Cassandra, there's something called ScyllaDB. They've taken a gigantic JVM-based kind of tool, and then they've re-implemented it in C++. There's loads and loads of things written in Go and Rust in this fashion as well. There's a load of this stuff, and the wonderful thing about Python is that it's just like a system call away in most cases, which is one of the reasons I tend to feel most comfortable in Python, and like a lot of us use Python here as well. I hope that's given you enough examples. Like there's loads of ones. You just think about, okay, what can I call in Python that's already written in something fast?
I think this is one of the benefits of probably the directions that Python as a language took many years ago, being, such a glue language in which you can actually use Python to glue together many technologies. And probably the reason why it's so useful in data science. But that's a topic for different discussion. It's almost the end of the panel, so it's 5 minutes. I would like, if you don't mind, asking all of you if you had any particular things you want to share with the audience as a takeaway gift after this panel.
I was gonna, can I say that? I was like, is it too much selling it? But I mean, so every search with a Kosher is carbon negative because we're putting green energy back into the system. So we're not just carbon neutral, we've been carbon negative for a while. I think at the moment we're even close to 200% carbon negative. So you can't go wrong. You might not always find the answer to your search query. So like our search results just are not as good as like Google, for example, which, we're not as big. We're a tiny team. But you can always have a go first, and then you've got a carbon neutral search that's done. And if not, you can use #G, and that will take you through to Google. So there you go.
I did not know about the #G thing. I'm switching my search engine tomorrow now. Okay. I have been using DuckDuckGo for a while so far, but now that I know that, because that's the main thing I use with DuckDuckGo, there's lots of search engines which don't necessarily have the search results of a $2 trillion company, weirdly. But maybe it's good to like go for a diverse ecosystem rather than just a monoculture in some cases. But the thing I would probably say is, if you are interested in any of this stuff, you can you could basically think about all the services in your own stack. We run a checker where I work at the Greene Web Foundation. So you can see which services are green and which ones are not green, which ones are green or not green energy. And if any of this is interesting to you, there's an awesome list. If you go to Awesome Green Software on GitHub, you'll find loads of examples of cool software which is like this that you could contribute to or be part of. Oh, there's a group called climateaction.tech as well, which is an online community that I'm part of and a few other people are. If you want to talk about this stuff in Slack, and it's not just Python, I'm afraid, sorry, but it's a really nice community. I'd recommend looking there because, it's gone from it's a nice big community of climate aware nerds just like yourself, and you'll find lots and lots of friendly faces. And I'll hand over to you now, I think.
I was thinking to go with use iGenius to make your data sustainable, but I think that's not a good one. So, I believe actually that you are going to get out of this session with one more question on your mind, and I think asking questions sometime actually is the way to start a revolution. So please, tomorrow when you are, hopefully not tomorrow, so on Monday when you are at your desk, send an email and ask your company what are they doing about sustainable AI. And I think this can really be a small action to make what we said here actionable for everyone. Thank you.
That's wonderful. Thank you so very much. I just want to say thank you so very much to all the speakers for agreeing. Having this has been really amazing. Having the pleasure to have this very interesting and different, but at the same time, we said complementary point of views on the subject, which is a nice thing to talk about. I was wondering if there's any other question from the audience before we wrap up. Oh, please, go ahead.
Okay, so I have a question that, as you said that AI needs to be sustainable itself in order to make other things sustainable. So could you please elaborate more? Are you talking about the GPUs, the data sets that we use to train the AI and the deep learning models? And more in the technical way, how AI can be sustainable?
So actually it's about the full cycle. So to put things in order, it starts with the use case. So we're speaking about big data against small and wide data. So if we don't need big data for a use case, why should we get, a 180 billion parameters language model to maybe answer a couple of questions and just say, hello to the end user? I'm just making an extreme example just to stress the fact that the use case is where you start. Then down the way, immediately after, I think you need to find the best architecture that serves this kind of use case. Of course, in this case, we're talking about the size of the data set and how many models you need to involve in solving that problem. But then from there, it's all about writing great code, making it composable. So I think, I don't know how many agree with the microservices approach here, but I guess a lot. For example, when we think of microservices, which sometimes can tend to be very expensive, because of course it's like building more software than you actually need, but you can monetize that over time. So at iGenius, for example, we have one product today, but the way we design microservices is thinking of a future where we can open each of these, which potentially can be separated products, into additional revenue streams in the future. So it can literally power your company to shift from product to platform quite easily, while actually complying with these principles as you build more sustainable software. So then again, we were speaking about the infrastructure of choice. So I'm sure now all public cloud providers have by now KPIs about the carbon footprint. So you can actually choose the best cloud provider with this respect by looking at their KPIs. All of these KPIs are available on their websites. And again, it's the end-to-end cycle. So I could get into more details, but I think the most important ones is starting with the use case and then designing the right architecture. Everything else will just follow.
You said about using less data when you just answer 2 to 3 questions. So I wanted to ask that if it is AI, so anybody can ask any question, so it can be biased, or you can say it's give error, because there are 2 types of system: rule-based and there is a logic-based. So in case of rule-based, it works. It's get an error just like normal chat box works in the websites. But in case of the not rule-based, we need lots of data. It's normal to use lots of data when the model is not rule-based, because anyone can ask any questions on the chatbot. So it's might get difficult for this chatbot to answer this question. But if we have a large set of data, so the chatbot can be trained well, and it can be data efficient, so it can answer well these questions to the user in terms of AI.
I think, again, this is about the use case, because, for example, we are providing an advanced conversational AI that is now on the market and is achieving success. We're using a small and wide data approach in very complex business intelligence use cases. And what we're doing to make it multidimensional and not rule-based is actually trying to understand the specific use case by designing a knowledge graph which is limited to the context. So by actually indexing entities of a specific use case in a multidimensional, I would say, brain, let's call it a business knowledge graph, we're going to somehow, first of all, create a layer of knowledge that contains actually potentially unlimited combinations of that information for the end user. Then you can leverage a composable approach, since you build this small capability, to actually scale by combining different type of technologies. So for example, we combine 3 core modules to make data talk. One for integrating data sources of different type, indexing their schemas with a small and wide data approach into a graph, and then combining natively the conversational AI to interact with that graph by handling context and a lot of other things. But what we're doing here is we're actually decoupling complexity, breaking it down into different, I would say, micro products that then, when you combine them, they solve the problem of a big model, a big problem at scale, without actually having even to pre-train it. So potentially you can also run it on the edge one day and achieving even better, I would say, recognition rates than 180 billion parameters shoot down for that use case.
So this is an example of consumption. All right. The other option would be intensity. Hugging Face just moved all their computers to run in Montreal, where the energy is super duper green. That is the other way you can get rid of the environmental impact of this stuff, by just being a bit more thoughtful about where you run your compute.
That's wonderful for wrap up. Do you have anything to add in? Oh.
No, I was just saying we also do this. We looked at which data centers run on green energy.
Yes, that's wonderful as a wrap up. I'm afraid we're running out of time, so there's no more time for questions, but please reach out to the speakers if you have any. Thank you very much, everyone, for joining, and another applause for the speakers for being here.